Hi, I'm Bindra. I'm an engineer with Microsoft. I work mostly in the cloud native DevOps and infrastructure space. And today I'll be discussing about ephemeral testing environments, their creation using GitOps. So the agenda for today, we'll first understand what ephemeral environments are, why they are needed. Then we look at the types of ephemeral environments and then look at a pattern for creating ephemeral environments the GitOps way for each pull request, right? Now, it may be like I'll check with you folks that how many of you have a good understanding of GitOps. Uh, okay, how many of you have worked on GitOps? So I understand like not many. So what we'll do is we'll take a detour, understand what GitOps is before we look at the pattern using GitOps in more detail. And towards the end, we look at the demos using the two solutions, one Argo CD application set pull request generator based, and the second one with Flux using custom controller. So moving on to what ephemeral environments are and why they are needed. So many times we find that when the application, like you create pull requests or create new features, initially you might not, certain categories of defects, you'll not catch them during the PR phase, right? Only when you say deploy it to a production like environment, maybe UAT or staging, right? Where you're hitting the actual backend services, you get certain defects. And the reason is that in the earlier, like in the PR or in the earlier integration tests, or you are just mocking the external dependencies, right? Like the databases, for instance, and you get certain these categories of defects only later on, like when you test in staging. So ephemeral testing environments are automatically created and destroyed. These are production-like environments, right? Uh, their lifespans are generally tied to the feature or the bug fix branch. Many times you don't, you'll not create them for all the pull requests. You might create them based on the branch name, like a filter of branch names. And in many cases based on PR comments. So for instance, if you contributed to the Kubernetes, say perf test or test infra repositories, there many times for significant changes, the reviewer is going to put a comment that okay to test, at which point like a multi-node cluster will automatically be spun up and then tests will be done against it. And then it will be destroyed, the environment will be destroyed. As I said, it's used for automated testing, but it can also be used for manual testing. And in some cases, it might not be tied to like a feature or a bug fix branch. For instance, if you need an environment for say 2 days, the QA team requests for environment for 2 days, in that case you'll not be needed. That will not be needed. Okay, so let's look at the different types of these ephemeral environments in the next section. So to understand the types of environments, we look at first the application which we are dealing. So this sample application, as I said, the code for all the sample application and the infrastructure repository, in fact, all the repositories is kept in a consolidated GitHub repository, which I've linked in this presentation deck. So the application is a Java Spring Boot application. It's a to-do API. So using this API, you can create to-do items and mark them as completed. The source code is in the application source code repository, and you can then the application is built and the images are pushed to a container registry. Now the deployment is in a Kubernetes ecosystem wherein this application has a front-ending service. Then it has a deployment with multiple pods, and since it persists its data in a Postgres database, yeah, there is a Postgres Azure Postgres service which it uses, and the Kubernetes deployments are on AKS cluster. Now, for this, with this application, if we were to create ephemeral environments, there are two main types of ephemeral environments. One is that for these ephemeral environments, you have a pre-created Kubernetes cluster, and then for each PR or a pull request, you will create a namespace, separate namespace. Okay. And the other one is that for each PR, other main categories, for each PR, you'll create a completely isolated environment. So for each PR, you will have all a different separate copy of each of the resources. Okay. Let's now maybe dig a bit deeper into these types of environments. So the first one is like a PR per namespace with shared cloud service. Okay, in this case, for each PR, we are creating a new namespace and we are having a separate copy of the deployment and Kubernetes service. However, all the deployments, they point to the same Postgres server, but they have their separate databases within that Postgres server, right? So yeah, again, they have separate deployments, separate namespaces on the Kubernetes cluster, but the deployments all point to the shared cloud Postgres service. Now within that Postgres server, each of these deployments points to a separate database. Okay, so though they use the same shared service, it's isolated. In the second kind, what we do is instead of the shared cloud service, we use the containerized version of Postgres. So Postgres is deployed as a container in each of these namespaces for each of these PRs. Okay. So this is the second variant of namespace per PR. Okay, where we are having a containerized version of the Postgres server. There is a third variation as well, where we can create within this namespace, we can have virtual clusters. Okay, uh, virtual clusters, and now we come to the completely isolated environments. So for each PR, we have a completely isolated environment with each having its own resource group with its own AKS cluster with its own Postgres database. So today we'll be diving into the completely isolated environments. Okay, and yeah, the complexity here is that first you have for each PR you first create that environment. So you create the AKS cluster, and then when that is up, you deploy the application to that AKS cluster, and you do all that in a GitOps way. So now let's first understand what GitOps is. So if you look at before we come to GitOps, let's understand the Kubernetes, the basic, the old kind of push deployments, right? So you have a YAML, you have defined in that YAML that I need like a deployment uh, with 3 replicas. Okay. So what happens is when you submit this request to the Kubernetes API server, it is first persisted to the Kubernetes document store etcd. Okay. So this is the first step, right? After, of course, the admission phase, this will be stored in the etcd. Okay. So now etcd, we know that we have there is a document in etcd which says that you have to create a deployment with 3 replicas. Now there is a corresponding controller which understands, okay, how do I create a deployment? And that controller then reads this and then it creates 3 pods, okay, for that deployment, right? Okay. So now you did a kubectl apply. We had the document in etcd and the controller which understood how to reach this desired state which has been indicated by this deployment YAML creates the 3 pods, right? So yeah, that's the first part of it. So now, suppose somebody comes in and says, kubectl delete pod number 3, right? So what will happen? For a few seconds, this third pod will get deleted, but the controller, which is continuously running asynchronously, will know that we've drifted from the desired state and will again create that third pod, right? So it again makes sure that we reach the desired state. So now what do we do if we want to change the number of replicas to 2? Okay, what do we do? So we edit the deployment, right? You'll change the deployment and change the number of replicas to 2, which will then change the desired state document in etcd and change the number of replicas to 2. And then the controller knows that the new desired state is 2, so it will now delete one pod on its own. Right. So what is the big problem over here, right? We have 2 pods, right? But in Git we still have 3 pods. Somebody went in and deleted one pod, but we don't know who deleted it and why it was deleted, because the number of replicas in Git is still 3, but in the desired state of Kubernetes, the number of replicas is 2 because somebody manually went and changed that, right? So yeah, so we don't know who changed it, why it was changed. So it's a big problem, right? Particularly if many people directly, change certain things in Kubernetes. So yeah, it's difficult to understand why the desired state was changed. So that's where GitOps comes in. So there is a GitOps controller with the responsibility that to keep the desired state of the manifest same between Git and the Kubernetes document store etcd. All right. So even if somebody now manually comes and does a kubectl edit and changes the number of replicas to 2, that git sync controller is again going to change the desired state to 3 because it will keep it in sync with Git, the Git repository. And we'll have the same number of replicas. And somebody wants to change the replicas to 2, they'll have a Git commit message that changing replicas, and they'll explain the reason that why that was done. And then the etcd replicas will be changed to 2, and then the controller will pick that and change the number of running pods to 2. So GitOps is basically that, right? Your desired state of the manifest is kept in sync with the Git repository. So all your operations are through that Git repository, and you can track each of the changes, that why they were done, okay, who did them, who made them. And so I mean, in most projects we see these days, GitOps is the standard way of doing things. Okay, particularly if you have multi-cluster deployments compared to push deployments, there are several advantages. Okay. Okay. With that, let's go to the next question. That what if we want to create cloud services? So GitOps works well for all these Kubernetes manifests. Now, can GitOps be used for creating cloud services, which are outside of the cluster? Okay, that is the next question we want to discuss. EKS or AKS cluster. If you want to create those resources based on a YAML in a Git repository or a YAML in this desired state store, what would you need to do? So what the requirement is, suppose I give a YAML of this format. Okay. Yeah. So suppose I have a YAML which I tell the version of Kubernetes, the number of nodes I want, and then it goes ahead and creates a cluster in your cloud provider of choice. Say here it's AKS, right? So what would that entail? So this is clear. The GitOps controller will make sure that this desired state reaches the desired state store of Kubernetes. Now what we need is a controller, say a custom controller, which understands what each of these terms means, and then it can go to the cloud provider. It can call the cloud provider APIs and then create this. and then when anything changes, it can keep it in sync, right? So that brings us to crossplane. So crossplane is a set of providers.
इधर खड़े
उसको मूविंग का क्या होता है?
वो मूव हो रहा है.
Okay. What is crossplane? It's not very important right now, but basically crossplane, for all the cloud providers, it already has these controllers, which based on these manifests know how to create the resources in the cloud provider. So for Azure, it knows how to create a Postgres database or a Azure AKS server. So GitOps is slightly clear. We can move back now. So now we want to create, coming back to ephemeral environments, we want to create these ephemeral environments in a GitOps way. What does that mean? That when you create a PR against the repository, we want to now go to some maybe, so there's one application repository where your application source code exists. You create a PR against that application source code repository. Now there is another repository, which is say your infrastructure, which your platform team owns, right? That could be one. It could be the same repository also, but let's consider that there is a separate repository which contains Helm charts.
Yeah.
Okay. So let's say Kubernetes manifest, or it contains Helm charts.
What is Helm chart?
Helm chart is Kubernetes manifest, deployment manifest.
Who has the question? Good. Which language are you using?
Mostly code JavaScript.
So
NPM
you get.
It's a package manager for kind of. Okay. So all right. So now there is another repository which has all these manifests. So suppose for an environment, for an ephemeral environment, if I need to create a Kubernetes cluster, a Postgres database, it has these manifests, right? The difference is you need something in the middle that when I create a PR, say PR number 3, right, with a git SHA, with a commit SHA of some XYZ, it passes these two parameters to that Helm chart, right? And that Helm chart you need to write in such a way that for PR number 2, we will look at that, right? We look at that. AKS cluster 2 gets created, Postgres database 2 gets created, right? Right? And then the difficult part is for a completely isolated environment. Now you want to deploy an application to that newly created Kubernetes cluster and linking all this together. So we'll see how that happens. We'll do it to and fro. We will start with a demo maybe, and then we'll come back. Okay, maybe this after this slide. So this pattern is called, as I said, pull request generator pattern. It comes from Argo CD pull request generator. So as I said, when you push something, there's a PR against the application repository. One thing which happens is you create the container images, you push them to the container registry, right? And then this pull request observer, in the case of Argo CD, this is a Argo CD pull request generator. In case of Flux, there's a custom controller which we'll discuss. But basically what it does is, it picks up the PR commit SHA, right, and the PR number and passes it to the Helm template. So the Helm chart accepts two parameters here, to keep it simple, a PR number and a commit SHA. Then basically for PR2 it will create a separate set of manifests, for PR3 a separate set of manifests based on that same infrastructure definition in the infrastructure repository, and then applies them to the cluster. So there are 4 different repositories, but to make it easier, what I've done is I've consolidated these into one repository. I've shared the link on my slide deck. So this one is the sample application source code. Then there is, so we'll have a look at this one first. When I'm creating the PRs, I didn't want you all to interfere and create like PRs against a public repository, so I made it a private repository. So, okay. Anyway, so this is the source code. As I said,
trust, man.
I showed trust with my own team. Didn't work. Okay. So yeah, it's, as I said, Spring Boot based application. There's a Docker file. Okay, and this application has just 3. So people who wanted to know like what a chart is. Yeah. So this is like, it's got a deployment YAML. I will maybe increase the font a little bit. Visible?
Yes.
Okay. Okay. So now the important thing is this requires like environment variables of the Spring data source, which is your like Postgres username, password, right? This Helm chart except when you create a deployment, it needs these three YAMLs, right? And okay, this is the first part of it. We'll now create a PR against this repository. Okay. What it is then going to do is it is going to use this infrastructure Helm chart repository. When I create a PR, okay, when I create a PR, what is going to happen is it is going to create a AKS cluster. So this Helm chart, let's look at the AKS cluster one first. So you see this, the name of this is AKS PR, and I'm adding the PR number, right? I'm adding the PR number. So that's why for every PR, this is going to be a new number. So it's going to be a new. Similarly, I've got a new namespace. The DNS prefix of this, like I'm giving the PR SHA, I mean ENV PR SHA, so that when I hit the endpoint of the API, this I know a predictable pattern. The interesting part is now when this AKS gets created, how do I now deploy the application with the Postgres database, right? So that is happening in this Helm chart, which is so Crossplane, as I said, Crossplane has Azure provider, AWS provider, wherein you define these resources and it creates corresponding resources on the cloud provider. It also has a Crossplane Helm provider, right? So the beauty of Crossplane is if I tell it that create this AKS cluster or like any Kubernetes cluster and then create this Helm provider, so it will wait for the Kubernetes cluster to spin up, and then what it is going to do is it's going to, this is the app Helm release, okay? This is the app Helm release, which is the Crossplane provider. Here I'm telling it, okay, the name again is just a concatenation of the PR number, but I'm telling it that for the pull a Helm, once pull this particular Helm chart from this repository with the version number 0.0.PR number. So when I'm creating a PR against the application repository, I'm pushing the Docker container image plus I'm pushing those three Helm charts which the application had in this format, and I'm pushing it to the container registry in OCI compliant, and I'm giving it the number 0.0.PR number, and I'm telling it that this is the application. The type is not important. The image tag is the values.pr SHA. So this is the commit SHA of that application, and the database, the Spring database URL is again, it's a predictable format, PR number, values.pr number, Postgres database. Username is also again predictable. The database, the password, I am setting it from a Kubernetes secret, right? So now I've seen multiple variations of this. Right now, I'm keeping the same secret. So all the Postgres databases that we created have the same secret. But in real scenarios, you can have different values for different teams, kind of thing, right? It's up to you. You can dynamically get it, send it to someone. But yeah, right now all the Postgres databases have the same password which is there in the secret.
How would it work with keyword or something like that?
It can work with the keyword because even in that way. So if you have a keyword, you still need to tell it whether all the Postgres databases have a single password. You can fetching from keyword and inserting it is not a big problem. Now, option is that you want three different possible passwords for three different teams. So in keyword, you need to have 3 entries anyway.
But what I'm saying, okay, each team will have their own managed identity, service principal. How will that go? Your managed identity is one.
You could have 3 different keywords for those 3 different teams.
Not keyword. Managed identity.
ठीक है.
हर टीम का खुद का identity रहेगा, right?
Yes.
The IAM role. I'm talking about what Bismillah was there. Remember the IAM rules to be here. So we also have the identity रहेगा. Now managed identities for the artifact, the Kubernetes. How will this transport keyword 3 different secrets?
So now who's creating? So the Git repo is the same. The branch against which the PR is generated is the same.
Okay.
So it's the platform team which is responsible for creating these ephemeral environments. Whatever team is responsible for creating these ephemeral environments, that team controls it.
Okay.
Now the thing which can change is that for certain teams, like you might want different Postgres passwords, but I mean, this is the simplest and easiest way. And many people don't use completely isolated environment because it's costly. Okay? And if you want to do it, again, it's up to us what we want to implement, right? You can have multiple secrets in the Kubernetes cluster synced from the key vault, and you can inject them based on some condition.
Yeah, look, you work with BFS, पैसे तो है, so they will create for these separate teams. वो COI लिखेगा वो लोग, वो team को देगा. They contract है, actually team मतलब दूसरा contractor को ही दे दिया समझ लो. And they have different contractors and there is a password. So they will have different identity. They not give the same identity structure. So Alan, how will that work in that case?
I think one thing which we have to put in context is that this is ephemeral. आपका PR जैसे merge हो गया, it will tear down, go away, along with database and everything else.
Yeah, but even that data, उन लोगों को they give it to separate. See, how did they work about it? They never give one person anything.
But the purpose of this environment is to catch the defects जो बाद में आने वाला है, right? In certain cases, तो most cases में क्या होगा? This will get spun up. You run the test and then you tear it down. Now there are some rare cases where you want that let them live as long as the PR branch is living.
Okay.
Now in that case, you can have this kind of a custom requirement कि कौन से team का किधर से create हुआ, but then it gets more complex. You add complexity.
Okay.
It's not needed. Okay.
Yeah, go on.
Please.
Please, if you scroll up, the integration part between the repository on line number 12, 17, that's basically what I understood, what I wanted to understand.
Yes.
When you already have a helm chart in your for the application, that helm chart, how does so this?
अभी होगा in the demo. So now we are starting with the demos. कितना time है? थोड़ा
हाँ, so what we can do is you can start a demo and we can have the teaser also in the meantime.
Sure. Because ये खाली Argo CD part है. I want to show the Flux part as well.
Okay.
Because that has a custom controller. But if you don't want, I will not.
No, let's do it. You're taking the trouble. Like people are coming here to learn also.
Yeah, okay. So first, what I'm going to do is
The only thing is that pizza also is getting cold. Think about that.
तो तू देना पिज्जा.
Okay.
स्पीकर को नहीं मिलेगा पहले.
हाँ?
स्पीकर को नहीं मिलेगा.
पेट तो देगा. तुम्हारा पेट तो देगा तुम. ठीक है. Anyway. So I've created two private repositories, one for the Argo CD based controller. Okay, now this has one open PR currently 24. What I'm going to do is I'm going to create a new PR against this repository, PR number 25.
ये उसको black white background में करना चाहिए.
इसमें खाली मैं PR create कर रहा हूँ और ठीक है. So that also I'm just create PR 24 to right.
Yeah, 25.
हाँ, अभी 25 बनाना है, right? So I'm creating a new PR. I'm basically using ऊपर जो है GH GitOps CLI. I'm creating a pull request number 25. Okay, so what we should now see is यहाँ पे there'll be very soon there'll be one more pull request. So 25 is created here. ठीक है? Very shortly I'm going to switching back to Argo. Right now इधर Argo CD में there's something called as an application set. For every what our application set does is for every PR it's going to create one Argo CD application. 24 is already there. In around 2-3 minutes 25 भी आ जाएगा जो हमने अभी create किया है. But not to waste time, so we are quickly going to dive into, and I think this will answer Varun your question. Okay. So first of all, ये 24 का application set जो है, I'm going to zoom in a bit, right? इसमें खाली दो चीजें पास हुई. So when my application got created, let's go what happened when the application. So right now, इस PR में there's only one check, right? The Docker container image is getting created. Very soon, Flux वाला Argo CD वाले में नहीं है, but मैंने जो custom controller लिखा है, you'll be able to see the second check that the environment creation in progress. But इसका commit hash is 58B725, right?
Yeah.
And so this is now complete, and PR number is 25. Okay. If I go to the packages, right? So this is basically your container registry. तो यहाँ पे git sha याद है ना तेरे को?
हाँ.
Okay. So yeah, ये दिख रहा है? ये अभी भी this 58, right? Additionally, if I go to the Helm वाला chart, there is this published. नहीं तो okay.
I created one PR, which is PR9 against this PBT, this second private repository of the application. I'm going to create one more thing. Let's create two environments. So this is the PR9 which I created. Now I'm going to create another PR10. So for 9, as you see, since this is my custom controller, I also update the PR itself on the git commit status that it's showing that creation of ephemeral environment in progress. What happened in the background? So this is the custom controller. So it said that new Flux Helm release created for PR9. What that means is my custom controller went to that infrastructure repo, passed in the git commit SHA and the PR number. It generated all the manifests, and now if I go to Azure, like we see that the naming convention is env. So this env PR9, this resource group got created. Okay, and in this, if we see, there's a AKS cluster and this Postgres SQL database. In the end, when the application comes up, that Helm release is going to deploy, and we'll answer your question on this. And we'll be able to hit the APIs and curl and add new entries as well, which we'll look at. And now we also created a PR10. So as you see, this custom controller saw that, okay, this new PR has been created. Okay, increase the font. So 35 seconds ago, this new PR has got created. So it will create a new Flux. Yeah, it creates, so Flux has this thing called as a Helm release, right? If you create a Helm release, Flux automatically creates all the manifests for it. And the good thing is, since this is my custom controller, we've also put a health check. So it keeps on monitoring that health check endpoint, and when that comes in, the GitHub status, that will be made green. So we'll at that point be able to curl that endpoint. Okay.
So which health step is that?
So again, so good point. So what we'll do is, I'm going to the repository, I'll increase the font so that you can see it. But so inside this consolidated repo, you will find one the shell script which I just ran. So there are two. There is management server install. This is the one with Argo CD, and this management server installed with Flux, which is with Flux. So this, again, as I said, this custom controller I've written, the source code is also there in one of these repositories. But to your point, Augustine, so when you're defining it, this is the YAML for the custom controller. So there is a GitHub PR repository. So there I'm telling it that if you go to app private one, you will see my repository there. But basically you tell it which Git repository to monitor for PR. So this is the user and the name of the repository. And then you tell it that, okay, health check URL template. In this you can have a pattern for either PR number or PR SHA. So I'm telling it that HTTP env PR number east to west. So my controller then keeps on hitting this till it gets a 200, at which point it will go update the GitHub commit SHA that, okay, this environment has been created.
Okay.
Yeah. So that's how you're doing it. And that's a good point. I'll also show you what the Argo CD one, like template, what that looks like. And I've based mine on Argo CD. So this is the Argo CD application set. Okay. Again, you tell it the GitHub repository which you are monitoring for PRs. Okay. And then you tell it, okay, where is your infrastructure Helm charts kept? So you tell it this is my infrastructure Helm chart, and then you pass the PR SHA and the PR number to that Helm chart. Okay. Here there is no health check, so it's all manual. Okay, so now it is showing for PR9, it is showing both the checks are, that means the environment has been created. So how can we check that? We'll do some curls against that PR. So it was PR9, right? So if we do this, let's go and hit PR9. So right now it's returning empty string. I'm going to just add some data. So let's so our environment was 9, right? East US 9. So I'm just going to change this to 9 over here. And what I'm doing is I'm inserting a test to do item, right? So when I insert this item, I should get a response that yeah, it's been inserted. Now if I go back to that page and if I do a refresh, it shows me that item, right? So basically I created the infrastructure, deployed the application on top of that, right? And now I'm hitting that application. And I'm also updating the GitHub PR that this environment has been created, right? So yeah, but of course this is like a custom controller. I also wanted to show you one discussion where I told you Stephen Prodden and all these guys. So this is Flux doesn't have a solution for this, right? So Stephen gave an idea of what this PR preview controller looks like, and but nothing is done. So when I created this as a sample, I put it there. So yeah, but this is again just a sample because this works only with GitHub right now. I have not extended it for other things.
कोड कमिट के लिए नहीं है.
So ठीक है, going back, ठीक है, तो यहाँ पे if you see इधर ये in the events it's also logging that environment is ready for PR9, okay, and for 10 अभी वो create कर रहा है, and quickly just slide पे जाते हैं. We'll come back to that वो question अभी कैसे देखेंगे. Basically we saw what the solution looks like for Argo CD. So this was for the, yeah, and this is what the Flux part is. So this is the custom controller which we've written. Rest of the parts are the same. Crossplane is creating based on the manifest. It's creating the resources in Azure. All this is the same. Repositories are the same. In case of Argo CD was doing this part of observing the repository and calling this manifest repository. Here my custom controller is doing it. And if you wish to see the code for the custom controller, Helm release. So उस PR के base पे we create a Flux Helm release, and then Flux takes care of going to the infrastructure repo, pulling the Helm chart and applying the manifests. So as I said, I've kept it like really simple, basic code, very quick code. One, there's a GitHub wrapper, and all the Flux wala is in that Flux wala helper. Okay.
So, so when you are creating new environment totally,
Yeah.
Resource group, AKS and all that,
Yeah.
that is created from some controller which is running in some AKS.
Exactly. Right now, the mistake I made is I ran it on kind. So that I had to recreate it. But it's on a Kubernetes cluster. And it's again based on Cube Builder. So yeah, you get the scaffolding and you just have to add like.
So that is your.
So now if you see, then we also see this resource group 10 coming up for the PR number 10.
So all the injection of the Helm, like the custom resource definition for Helm, that gets injected via Argo, or like, so you said that there's one is the Argo and then the crossplane.
Yeah, right.
So the custom definitions, how do they go into Kubernetes? Like
Correct. So in case of Argo, when you have a pull request, Argo is observing the pull request. So it comes to know what is the pull request number and the SHA, right? It also knows which is your infrastructure repo, which has the Helm chart. So it calls that Helm chart passing these two values. And when it gets it, the Argo CD application set also applies that. And the Argo CD application applies it to the cluster. In my case, what I'm doing is I'm observe the PR and the helper which I showed you, the Flux Helm release. I'm creating that resource on the cluster. And from there, actually, Crossplane is the one which reads those manifests and creates these cloud resources.
So it's like a custom integration.
Yeah, for Flux, this is like a, I mean, as I said, it's handling only GitHub integration, right? So it's like a sample control.
Okay, one reason you just kindly want to do local development, right? You want to make sure everything is working on.
I thought because others can just run this and follow that.
Because what if we wanted to do completely local development without any suppose network connection in? everything local. Then
But then how will you create the cloud resource?
there's no.
Correct.
So is there a way to emulate that on the machine?
Yeah, then you use a cross-plane provider for something which uses something which can be done locally.
Something
So there are कीमू type मतलब ऐसा.
So crossplane has like provider.
Yes. So if you go to crossplane, before I go to crossplane, I just want to run you through the scripts for Argo and for both of these. But for Argo, it's quite similar. But you create a new kind cluster. If you have an existing Kubernetes cluster, you don't need to do this step. Then you install crossplane. Okay. Then crossplane, you need to install the providers you want. So in our case, we are installing the Azure Jet provider, and then you're installing the Azure Helm provider. Yeah, these two providers, and then you create the secret, right? So as I said, for Postgres password, I'm creating a secret. Okay, and then I'm creating for Azure credentials. So basically, the crossplane provider for Azure will need to call the Azure API, right? So it will need some credentials. So it accepts a secret. So I'm creating that secret so that it's available for crossplane. Okay. Similarly, this Helm, the OCI registry, when I'm pushing the chart, there's a credentials to access that, and then I'm installing Argo CD, right? And then basically I'm logging into Argo CD, and I'm creating the repositories for the application as well as for the infrastructure.
So crossplane is also running in
The power lower.
Everything is running right now on kind.
master.
Right now everything is running on kind.
But ideally, like what
It will run on a cloud hosted on second thoughts, because then it will keep on running even when whatever happens to your machine. So you should have to do that.
I was trying to see what providers are supported by crossplane.
Huge. And crossplane is also CNCF, right? And what crossplane has done is they've come up with a tool called TerraJet. So anyone who has a Terraform provider, they just run it and generate the crossplane providers. Yeah. So even the Azure Jet provider I showed you was generated that.
One more question. In cases wherein you want upgrades to an application, right? Is this testing only required when you are actually going on creating a completely new PR?
Yeah.
Or because let's say there was a problem with 9, and if I want to basically understand the older versions of 9 had some problem with, did not have a problem, then I'm creating a completely new environment. What about the
When you push and commit to 9,
no, so yeah, so let's say
that is handled.
there are upgrades. There are times there is a version 8 on which you let's say deploy 9. Now up until 8 everything was working fine.
Version of an application.
Yes, version of an application. So up until 8 everything was working fine on a particular EKS cluster, which will also have other applications.
Correct.
I cannot expect my entire
So this is, so 8 is deployed in production, right?
right,
So now when you make the change for 9, that is a PR.
right,
So in that PR, you will have an infrastructure which is similar to production,
right.
and then this 9 deployed to that, not to production. So in your ephemeral environment, you are deploying 9.
Directly 9. But what about the other applications that I might also have on the cluster?
So
in terms of the
all these microservices, you
Yeah.
have your, so then you have to orchestrate that, right? So
Right. So
exactly.
that will be an additional step when I firstly completely. So
Exactly.
after the AKS part, there will be another, let's say, a step in between, which will also, let's say, deploy other applications upstream, downstream, etc. And then comes my application, which will then check.
Exactly.
Subsequent pushes to the branches of
It will create a new one. So it's the same, it's the same environment. So if you look at the helm chart, right? Only thing, so let's look at the helm chart. So that will make it clear.
So but like
Just a second.
no,
Sorry.
it's okay. So like, I was just wondering like
So if you look at the application helm chart, right? This is the application helm release. So the PR number remains the same. So all the environments, so the AKS cluster, it has the PR number. So even when you push a new commit, the PR number remains the same. So only thing which changes is this helm release, because it uses a commit SHA.
yeah.
So here the PR value SHA. So only on that same cluster,
Okay.
this
There is
new
an upgrade.
exactly.
That's that.
Yeah. And again you will see that. So creation and progress, and you will see a green tick when it's created with the flux one, of course, not with the Argo.
Any more questions to Mani?
Okay, Mani, thanks for a great session, in depth and all.